Okay, so we are at number 47, rectangles, rhombi, and squares. And our days are a little bit off, but I'm not going to change the numbers because the notes are already done. So we're just leaving them like they are. Okay. All right. So our question is, what are the properties of diagonals of rectangles, rhombi, and squares? And then we will recognize and apply properties of those rectangle, rhombi, and squares, and then determine whether quadrilaterals are a rectangle, a rhombi, or a square. So for the properties of rectangles, a rectangle is a parallelogram with 4 right angles. So if a rectangle is a parallelogram, then automatically we know that a rectangle is going to have the same properties of a parallelogram. So that list of properties that you have about parallelograms, they apply to rectangles. However, we are now adding information. Now we're adding that a rectangle has 4 right angles, and that's what makes it a specific type of parallelogram. Make sense? So parallelogram is the big picture, and then there are specific types of parallelograms. The first type of parallelogram is a rectangle. Okay, so by definition, a rectangle has the following properties. All 4 angles are right angles. That's what makes it a specific type of parallelogram. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. Those 4 things are all properties of parallelograms, all right? Those are all 4 things that we already knew. And so now, in addition, here's a new thing. This is probably something you should highlight. The diagonals of a rectangle are congruent. So now, a rectangle is a specific type of parallelogram in that it has 4 right angles and the diagonals are congruent. So this is what makes it a rectangle. So then, of course, you got a card that has to tell you if a parallelogram is a rectangle, then its diagonals are congruent. So if a parallelogram is a rectangle, then its diagonals are congruent. So a rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. Y'all know that's what they do like on TVs and stuff too. Okay. If JK is equal to 12 feet and LN is equal to 6.5 feet, then find KM. So we know that JK is 12 feet and LN, which is down here, is 6.5 feet. And they want us to find KM, which is all of that, right? So what is KM equal to? Oh, that's my Google Classroom. So what do we get? 13. How do we get 13 feet? Perfect. Okay, so let's talk it through. So we know that LN is equal to 6.5, right? So if LN is equal to 6.5, then that also means that JN is equal to 6.5 because in a parallelogram, the diagonals bisect each other. Right? So that means that JL is equal to 13. We just did that with a little math, right? All right. Then we know that JL is equal to KM because it's a rectangle. And in a rectangle, the diagonals are congruent. So then that means that KM would be also equal to 13. And that's like the quickest version of a proof that I could do, but that's the idea, right? Questions? Does that make sense? All right, I'm moving on. Okay, quadrilateral RSTU is a rectangle. If the measure of RTU is 8x plus 4 and the measure of SUR is 3x minus 2, then find x. So let's label some parts. So RTU is going to be this angle. Oops, I don't want to do that. Is going to be this angle here. Oh, my goodness. All right, there we go. So that's going to be 8x plus 4. And then SUR is this angle, and it is 3x minus 2. All right? So then what's x? What's x? So let's kind of talk through it. So this is a rectangle, right? So if it's a rectangle, we know that we have 4 right angles. So all of these are right angles, right? But if it's a parallelogram, then because a rectangle is a parallelogram, then we know that opposite sides are congruent. Right? Make sense? Okay. All right. So then now we know that this triangle is congruent to the other one. And when I say other one, I mean this one over here. All right. So now these triangles are congruent, right? And they have this right angle in common. All right. So if they're congruent and this angle is 3x minus 2, then that means this angle over here has to be 8x plus 4, right? Because the two triangles are congruent. Make sense? Yes, no? Tell me now if it doesn't make sense. Why y'all let me do that? Because that's so wrong. Let me go back. Because y'all not even paying attention. I'll it. Okay, it should be, this triangle should be the green one. Does that make more sense now? Yeah. Okay, so now these two angles are congruent. So this one is 8x plus 4. And so then 8x plus 4 plus 3x minus 2 has to equal to 90 because these two angles here have to equal 90 because then you have this right angle down here that's 90. So that's 11x plus 2 is equal to 90. And then 11x is equal to 88. And then x is equal to 8. Questions? Yes? No? Okay, my apologies on the confusion with the triangles. Let's keep it moving. So we know the diagonals of a rectangle are congruent. So if the diagonals of a parallelogram are congruent, then we can say that it is a rectangle. So the converse is true. The converse is true. Okay. So some artists stretch their canvas over wooden frames. This allows them to customize the size of a canvas. In order to ensure that the frame is rectangular, before stretching the canvas, an artist measures the sides and the diagonals of the frame. So let's write down what he came up with. So AB is equal to 12. BC is equal to 35. CD is equal to 12. And AD is, or DA is equal to 35. Then it tells us that BD, that's going to be this one, is equal to 37. And that AC, this one, is equal to 37. So how can the artist be sure that the frame is rectangular? How can the artist be sure that the frame is rectangular? Well, we don't know that they bisect each other. It doesn't tell us that. It only tells us the length of the diagonals, but for sure, the diagonals have to be congruent. Does it matter? Does it matter about the other sides? I mean, they're important for us to know that, bless you, that it's a parallelogram, but in order for it to specifically be a rectangle, then those diagonals have to be congruent because that is a specific property of a rectangle. Okay. All right. So quadrilateral JKLM has the vertices that you see there in the ones in the picture. Determine whether JKLM is a rectangle using the distance formula. So if we want to determine whether or not JKLM is a rectangle and we're going to use the distance formula, then what information do we have to come up with, or what information do we have to show in order to say that this image is a rectangle? So we're going to use the distance formula and do what? Find the distance of what? What are we finding the distance of? That's going to help us to know that JKLM is a rectangle. We have to find the distance of the diagonals. Does it matter if the side, if the opposite sides are congruent? No, because that's only going to tell us that it's a parallelogram. Does it matter if the opposite sides are parallel? Nope, because that's only going to tell us if it's a parallelogram. So we specifically have to look at the diagonals to determine if it is a rectangle. And so that means that you have to figure out, is JL equal to KM? And so that's what I need you to figure out right now. Is JL equal to KM? All right. Brian, not you. Brian Lopez. What did you get for the length of JL? Brian?
I'm not done yet. Could I get a few more minutes?
Sure.
Okay. For JL, the distance I got was 7.
Okay, tell me what you did. So we did the square root of,
Of, let's see. It was x2 minus x1 squared.
tell me the numbers.
Let's see. 3 minus -2,
Mm-hmm.
and then it was -2 minus 3.
Okay. So that's going to give us a square root of 25 plus 25, which would be the square root of 50. Okay. Then that's going to be 5 root 2, right? Okay. And then Km, what would I do for Km? Brian? What would I do in order to find KM?
It was 0 minus 1,
Mm-hmm.
and then it -3 minus 4.
Yep. All right, so 0 minus 1, that's 1 squared is 1. -3 minus 4 is -7 squared is 49. So that's also going to give me the square root of 50, which again is 5√2, right? Because 50 is 10 times 5, and 10 is 2 times 5. So that's 5√2. So are those equal?
Yes.
Yes, so those are equal. So is JK equal to LKM? Yes. So is this a rectangle? Yes.
Yes.
Okay. All right, questions?